Let's set up the hypotheses and figure out a test statistic. The two groups are the mothers who smoked and the mothers who didn't smoke. I am labeling the first one A and the second one B. You're welcome to switch those labels if you wish. And the question is, could the difference in the birth weights of the two groups be due to chance alone? The question, of course, is not about the sample. It's about the populations from which these groups were drawn. We only have a sample of 1174 mother-baby pairs, but if we had the entire population, then it could be that in the population, the distributions of the birth weights are exactly the same for the smokers as well as the non-smokers. We're seeing a difference in this sample just because of who got selected in the sample by chance. Or it could be that the difference in the sample reflects a difference in the population. That is, in the population, the babies of the non-smoking mothers were a tad heavier, on average, than the babies of the mothers who smoked. To help us decide between these two hypotheses, we need a test statistic, and let's remind ourselves, group A are the smokers and B are the non-smokers. The natural test statistic is the difference between the averages of the two groups. And every time you say difference, you have to do one minus the other, and so I'm just going to calculate the difference as the non-smokers minus the smokers. Again, you're welcome to do it in the other direction if you wish. But if we do it in this direction, group B average, that is non-smokers average minus smokers average, then the alternative is saying that this difference should be positive. The alternative is saying that the non-smokers had heavier babies on average than the smokers, and so large values of this statistic will favor the alternative. Now we have to see what the null hypothesis predicts this statistic will be. We have to be able to simulate this statistic under the null hypothesis. How do we do that? The null hypothesis says that in the population, the two groups have the same distribution. How from that do we simulate the group B average and the group A average? We don't have the population, so we can't sample from it. But there's a very clever idea that allows us to simulate this difference under the null. And it relies on the fact that if the null hypothesis is true, then the two distributions of birth weights are exactly the same, so it doesn't matter which birth weight is labeled smoker and which one is labeled non-smoker. The label doesn't matter. You'll get the same distribution either way. And so if you take our 1174 birth weights, each one is labeled smoker or non-smoker, you could randomly shuffle the labels and you should get the same distribution of the two groups. If the null is true, all rearrangements of the birth weights among the two groups have the same chance. They're equally likely. Just as likely as the one we got. A rearrangement is formally called a permutation. What we're going to be doing is called a permutation test. So here's the plan. We are going to shuffle all of the birth weights and then assign some to group A, the smokers, and the rest to group B, the non-smokers, maintaining the two sample sizes carefully. And we will find the difference of the averages of these two shuffled groups. That will be one value of the test statistic simulated under the null hypothesis. And then we just do this over and over again. Shuffle all of the birth weights, label the right number of them smokers and the right number non-smokers, look at the difference between the averages, and just keep going. We will get simulated test statistics under the null hypothesis. We can look at the distribution of these test statistics. That's what the null hypothesis predicts our statistic ought to behave like. And then we can compare with the statistic that we actually got. All of this, you will recognize, is exactly the same as the process we have taken for every other test that we've done. The key here is to be able to simulate the statistic under the null hypothesis. Let's do that.